Okay, complete the graph below. Some of the results have been plotted for you. You should complete the graph. You should plot the data from the table above and draw a line of best fit through all the points. When it says through all the points, it means as close to the points as possible. Okay, so don't worry about doing dot to dot. We don't do dot to dot. Okay, so there's the data, and here's the graph. Okay, unfortunately I'm going to struggle to show both pieces at once. So we're looking at the change in mass. Concentration should go over here. So the change in mass for the first one was 2.2. So for 0, it was a total of 2.2. So here, so there's 2, and each of these is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each small square. So each small square equals 0.1. Makes that much easier. So 0.2 is going to be there. Oh, sorry, 2.2 is going to be there. Next one I've got is 0.1, which is here, and that goes up to 1.15. So there's 1, 1.1, and 1.15 will be in between going there. 0.2, which is here, is at 0.25. So there's 0.1, there's 0.2, 0.25 will be in between. And the rest of the points are done for me, so I've plotted them. Now I need to do a line of best fit. And I can see here clearly that if I just use my ruler, it's not a straight line. Okay, so I don't try and force a straight line. It doesn't look like a straight line. I've got points, it's obviously a curve. I'm going to move my page around a little bit, make it easier. I'm just going to practice. So what we're doing now is some muscle memory. We're making sure that my brain knows the pattern it's trying to follow. And as soon as I'm happy, I put my pen down and I draw a smooth line of best fit. Okay, so you'll notice there it doesn't go through any of the points, but that's absolutely fine. It's not a dot to dot, it's obviously a curve. What I haven't done is the horse's tail, the shading idea. Be really careful with that. Okay, that will never get you the mark. I've got a point above the line here. I could have moved the line possibly down a little bit, but that's absolutely fine. The mass of the potato does not change when concentration of solution inside the cells equals concentration of solution outside the cells. Determine the concentration of sugar solution inside potato cells and use the graph above. Okay, and it's worth 1 mark. So what I need to do from this is the mass of the potato does not change when concentration equals inside the cell equals concentration outside. So determine the concentration of sugar solution inside the potato cell. So I'm trying to find when is this true? When do I not get a change in mass here? So I'm looking to try and read off what is that point there on my graph. Now your graph might be slightly different. That's absolutely fine. Okay, even if you've done your line of best fit dreadfully, you're still absolutely fine, provided you you use your graph. Okay, so in my case, 0.2, 1, 2, 3, 4, 5, 6. So each one of these. So I think that's 0.26 according to my graph. Okay, the mark scheme says a little bit lower than that. They've also drawn a better line of best fit than I did, but it would be absolutely fine. Okay, the important thing is I use the data from my graph. As soon as it says use the graph, I would always draw on the graph. Okay, so the fact that I've got that little arrow there pointing to that point just shows the examiner I know which bit I'm looking for. I'm looking for when does the mass not change.